Approved document is guidance created by government to give you an idea of how you can comply with the building regulations. It's not the only way of doing it, but if you follow the approved documents, you can be fairly sure that you're going to satisfy the requirements of building control. Approved document L is on energy efficiency of buildings. There's been some changes just to improve the energy efficiency of buildings as we work towards 2025 and zero energy or zero carbon buildings. And the big change is that we had 4 volumes. We had parts 1A and 1B, which were for dwellings, and it was split into A and B, which for new build and refurbishment, and then volume 2, A and B, which were again for refurbishment and new build, but for non-dwellings. And parts A and B have now been combined, so one document now, or one volume, covers both new build and refurbishment for both dwellings and non-dwellings. U values show you the amount of heat flow through the fabric of a building. And that's by individual element or by assembly. U values, the lower the number, the better the thermal insulation of that component and that element. As far as roof lights are concerned, it's looking at the whole construction, so it's taking account of the glass, the frame, and all the parts that make up that component, that roof light in this case. Quite a big change is that the way we calculate the U values has changed. So for many years it's been calculated based on the roof light orientated in the vertical position, which doesn't make sense because roof lights go on a roof and they're normally installed in a horizontal position. It's just a hangover from many years ago when the only thermal performance that was considered was the glass that you put into the roof light, and to keep it equivalent or comparable to windows and the glass that generally goes into a building, because most glass areas are vertical, it was just always calculated in the vertical. When we had to start taking into account the frame and the whole assembly, it wasn't just the glass, that tradition was maintained. But now we've said, look, it makes more sense, especially as we're trying to get better performance from our buildings, that we actually calculate it in the orientation in which the products are actually used. Upstands were really a loophole in the regulations previously. There was no specific guidance on upstands at all. So again, to try and improve energy efficiency in our buildings, the government has realised, and the industry, that there needs to be some guidance on upstands. The initial suggestion was they should be the same performance as the roof, which is quite a jump from having no guidance at all. So there was an agreement that we should go for a figure of 0.35, and that is only though for upstands that are constructed on site, because a lot of roof light products come with an upstand built into them, and for the industry to make the jump to providing a 0.35 U value is quite a considerable jump. There was a concession this time around. If the upstand is supplied with the roof light by the same supplier as part of the same purchase, so a performance figure could be quoted for the whole assembly as one, then it only needed to achieve the same performance as the roof light. But when the upstand's constructed on site by the builder, or the components are supplied by someone else separately from the roof light, then it has to be 0.35. Roof lights generally for flat or very low pitch roofs and mount on an upstand. A roof window fits in pitched roofs, very often a tiled roof, and they're in plane with the tiles in the roof. So the roof windows are still treated as a window, as a vertical element, but you do have to apply the factors in BR 443 for the angle at which they're actually going to be installed. We've talked about just the fabric elements of the building so far, which are all the components that go into making a building, but ultimately to prove building regs compliance for energy efficiency, the builder or designer has to prove that the total energy usage of the building complies with Part L, and they do an overall energy calculation for the building as built. That then is compared against a theoretical building called the notional building, and that gives a target value that you have to achieve or exceed. And those target values are, the figures that go into a building to get the target value are also quoted in approved document L, but they're always stiffer requirement than the individual requirements for the actual building. So the fabric values for the actual building are always the absolute minimum for that component you can put into a building. But if you're going to achieve the target overall energy efficiency from the notional building, you will need to put better performing elements in, or some of them anyway, to offset poorer performing elements to achieve the target value. Obviously, energy efficiency of the building will improve. You will get lower heating and energy bills for the building. So, and as we move towards 2025, at which point fossil fuels will be prohibited from being used for heating a building, so no builders will no longer be able to install gas and oil-fired boilers. And the alternative heat sources, such as heat pumps, can't generate the same heat that a fossil fuel boiler can. So to keep temperature of buildings at a comfortable temperature for everyone, the fabric of the building does have to be much more energy efficient, and this is seen as a step towards that position for 2025. Building regulations seem to be reviewed roughly every 3 years, 3 to 4 years, so that 2025 would fit into that time frame, but the work starts long before the requirements are published, so probably the work has already started somewhere that we haven't seen yet, and there will be consultations and input from industry as they work towards the 2025 date, because that's the date they will expect to be getting it published to come into effect. But it's roughly a 3 to 4 year timescale between revisions to the standards. We can certainly help guide people how to calculate the performance for glazing and for roof lights. We can point them in the right direction for what they can do to improve performances. And we've talked about U values, but air tightness is also very important to achieve the thermal performance of a building. And again, we can give guidance on what may be the better products to give good air tightness as well as thermal performance. And it's not only the product, of course, it's the way you integrate the product into the building and into the surrounding fabric as well. So we can certainly help give guidance in that area. It'll be interesting to see how much further they can go improving fabric, because we're getting to the limit as to how far we can go, and then other changes will have to be made. It can only be a good thing, because it's helping save the planet. It will save energy, so buildings should be cheaper to run for the property owners or the residents in the future, but it will inevitably increase prices, I'm sure, of building costs of buildings. But it also helps that as more stringent requirements come in, it helps push innovation in the industry. It forces us all to look at what we're doing and try and find better ways of doing it. So it can only be a good thing.